Hello everyone, this is Group 3 and we are presenting our project on OLED, Organic Light Emitting Diodes. So here are the members of Group 3, Ashish Meena, Apurv Krishna, Dhananjay Bagul and Charchit Bharani. So let's start with the introduction about OLED. What is OLED? OLED is a light emitting technology made by placing a series of organic thin films between two conductors. When electrical current is applied, a bright light is emitted from this layer. Moreover, it is used to make displays in various devices like television, cell phones and flexible displays. It is much more efficient than LCD as it doesn't require a backlight for functioning, which reduces its power consumption. So let's get started with the structure of OLED. As you can see from the given diagram, the topmost layer is cathode. It injects electron when current flows through a device. Second layer is emissive layer. It is made up of organic plastic molecules that transport electrons from cathode. This is where light is made. Third layer is organic layer. These are made up of organic molecules or polymers. Fourth is conducting layer. It is made up of organic plastic molecules that transport holes from anode. The second last layer is anode. Anode removes electron when current flows through a device. And the last is substrate, which are clear plastics, glass foils, which supports the OLED. Now let's talk about the working. Electrical current flows from cathode to anode through the organic layer, giving electrons to the emissive layer and removing electrons from the conductive layer. Removing electrons from the conductive layer leaves holes that needs to be filled with electron in the emissive layer. The holes jumps to emissive layer and recombines with the electrons. As the electrons drop into the holes, they releases this extra energy as light. The color of the OLED depends upon the organic layer and intensity is dependent on the current. So now the biggest question is, how is an OLED prepared? In fabrication, there are three main steps. First is cleaning of substrate, second is coating and annealing of hill and emissive layer, and third is deposition of cathode. In cleaning of substrate is cleaned with soap and DI water, then it is placed in Teflon sample holder. In coating and annealing of hill and emissive layer, a coating of MEHPPV is done, then it is placed in a spin coater. For deposition of cathode, we will use gallium indium dots on the surface, and for a better understanding, we will see a video.
Starting with an ITO coated slide, most of the ITO is removed in order to leave metal stripes. Because the metal is transparent, an ohm meter is used to check which side has the metal on it. Thin strips of tape are put down to mask or protect the metal. The slide is then put into an acid mixture to remove the rest of the metal where the tape doesn't cover it. The slide is put in acetone and isopropyl alcohol to clean the metal surface before the PEDOT PSS is deposited. The slide is put into a spinner and PEDOT PSS is spun on and then baked on a hot plate in order to get a uniform thickness of a durable film. This film helps to get a good electrical contact between the ITO metal and the TPD organic layer. The organic layers are deposited by evaporation. First, a shadow mask is put on the slide to make sure that the organic layers are deposited only in the center and that the metal is still available on the edges. Then, the slide is loaded into the thermal evaporator. The material to be evaporated is loaded into little crucibles in the evaporator. To deposit thin films by thermal evaporation, the films must be deposited at a very low pressure, so the air does not interfere with the formation of the thin films. The evaporator is pumped down to a pressure of 10 to the minus 5 torr, about 10 to the 8 times less pressure than atmosphere. After the evaporator is pumped down, the crucibles are heated up and the films are deposited onto the slide. After the first set of thin films, TPE and ALQ3, are deposited, the evaporator is opened. The shadow mask is changed to deposit thin strips of metal crossing the top, and lithium fluoride and aluminum are loaded into the evaporator. The evaporator is pumped down again, and more thin layers are deposited onto the slide. Then the device is finished and removed from the evaporator, now ready to test. Does it work? It does.
Now let's see types of OLED. So first type of OLED is the passive matrix OLED. In this, the anode strips are arranged perpendicular to the cathode strips. The intersection of cathode and anode makes up the pixel where light is emitted. It is relatively easier to make. On the other hand, it uses more power. It is suited for the small screen cell phones, PDAs and MP3 players. Second type of OLED is AMOLED, which is active matrix OLED. They have full layers of cathode, organic molecules and anode, but the anode layer overlays a thin film transistor array that forms a matrix. This TFT determines which pixels get turned on to form an image. It relatively consumes less power. AMOLEDs can be best used for computer monitors, large screen TVs and now the third type of OLED is the transparent OLED. In this, all the components of OLED are transparent, that is emissive layer, conductive layer, cathode, anode and substrate all are transparent. These are up to 85% as transparent as their substrate. It allows light to pass in both directions. Now the fourth type of OLED is the foldable OLED. These OLED have substrate made up of very flexible metallic foils or plastics. They are lightweight and quite durable also. The foldable OLED displays can be attached to fabrics to create smart clothing, such as outdoor survival clothing with an integrated computer chip, cell phone, GPS receiver, and OLED displays sewn into it. Now the fifth type of OLED is the top emitting OLED. In this, the substrate can be solid or reflective. These are typically a type of AMOLED. These can be greatly used for smart cards. Now the sixth type of OLED is the white OLED. White OLEDs emit white light that is brighter, more uniform and more energy efficient than that emitted by the fluorescent light. White OLEDs also have true color qualities of incandescent light. OLEDs can be made in large sheets. They can replace fluorescent lights.
Next question is why OLED matters. It matters because of its efficiency. It displays brighter and clearer image than LCD or LEDs. It has got extended viewing angle. It is thinner and it can have flexible as well as transparent displays. In the following table, we can see the difference between OLED and LED. Here we can see the difference between LEDs and OLEDs. We can clearly see the sharpness in OLEDs. We can achieve higher pixel density with OLEDs, which makes our viewing experience great. Now let's have a look over the advantages of OLED. First is OLEDs are biodegradable. Second, OLEDs are thinner, lighter and more flexible as compared to the crystalline layer in LCDs or LEDs. Third, OLEDs can be folded and rolled up as in case of rolled up displays embedded in textile. This is because the substrate used in OLEDs is plastic rather than the glass used for LCD or LEDs. OLEDs are brighter than LEDs. They have greater artificial contrast ratio because the organic layer of the OLED is much thinner than the corresponding inorganic crystal layer of an LED. The conductive and the emissive layer of an OLED can be multi-layered and does not require glass, which absorbs some part of the light. Now let's have a look over the present development with OLEDs. OLEDs are used in the following technologies: Apple iPhone X, Microsoft HoloLens, LG's Rollable TV, Apple's AirPlay 2 and HomeKit, and the newly introduced Samsung foldable phone. And now we will have its challenges and problems. While red and green OLEDs films have longer lifetimes, blue organics currently have much shorter lifetimes. Manufacturing processes are expensive right now. Water can easily damage OLEDs. It is expensive as compared to LCD. OLED display quality are even worse as compared to LCD when subjected to direct sunlight. Limited market availability.
Now let's see some future prospects of OLED. It can be used for making transparent and flexible displays. Manufacturers are working to improve the device response time. The newspaper of future might be an OLED display, and it can also be used for automotive dashboards, billboard type displays, home and office lightings.
Well, certainly it ain't impossible now. Now we will take your leave. Here are some of the references that we used. Thank you.